So let's see what we have here. We have a wall here, we have a floor there, I have a beam up here, I have a tension coming from it. The beam itself is 4.2 meters long, and the mass, we don't know. From the distance from here to here is 1 meter, and I know that the tension in the cable is 1700 newtons. What I want to know is, what's the mass of the post? So I'm trying to find the mass of the post. I'm trying to figure out that from the tension. What do I do? I'm going to look at the forces acting upon it. So I'm going to draw a free body diagram. I've got a force tension coming off of there of 1700 newtons. I've got a force gravity going down. If I put my fulcrum there, I don't have to worry about my hinge. Whenever I'm dealing with a state of rotational equilibrium, I know that my torque clockwise equals my torque counterclockwise. So I try to think of all my torques in the clockwise direction. It looks like this force gravity is going in the clockwise direction. So I've got the mass of my beam times 9.8, and its distance from the fulcrum. If the whole distance was 4.2 and the top part was 1, the force gravity acts in the center of the beam. So it should be at 2.1. Now I think about my torques counterclockwise. This one, luckily, is already at 90 degrees. So it's always torque perpendicular, or perpendicular force times distance from the fulcrum, which reminds me I didn't do something for the first part. The first part, I have to break that into its perpendicular forces. So I imagine that part there is what I'm after. Do I have any angles? I'm hoping the question gave me an angle, and it did. 60 degrees in here, which means I've got 60 degrees in there. Am I looking for sine or cosine to find the perpendicular force? I'm looking for cosine. That is going to equal our torque counterclockwise, 1700 newtons, and its distance from the fulcrum is 3.2 meters. I'm now just trying to solve this for mass. I'm going to divide both sides by 9.8 times 2.1 times cos 60. Let's see. I need to find my calculator. I should definitely be more organized before I do this, but I'm not. Calculator in degrees. So I have 1700 times 3.2 divided by 9.8 times 2.1 times cos 60. I get a mass of 528.7 kilograms. I'll hopefully do a better job next time I do this.